Okay, here it is, the world famous AA gradient.
Big A minus.
Sometimes you'll hear it called the alveolar air equation. We're gonna just, we call it the AA, or the AA gradient. And it's big A, little a. And it's important that it's written that way because that's the distinction. What we're gonna be looking at is P big A, O2, alveoli, little a, how much is getting into the bloodstream. So how much is getting here versus how much is getting here? Because ideally, if it gets to here, it should get to here, right? We got it in the lungs, why isn't it getting it to where it needs to go? So the P big A is a formula. P little a comes from your ABG. So I'm going to show you how to get the P big A. And I'm going to write it out longhand first, and then we'll break it down. So the P big A is your FiO2 times the barometric pressure minus the partial pressure of water. Just don't get freaked out yet, okay? Minus the patient's PaCO2 times 1.25.
And then we're mathematicians.
Yeah. You will also sometimes see it as the PaCO2 divided by 0.8. I don't like it to divide. Most people don't, so I'm not gonna do it. I'm gonna do it this way. I just want you to know if you see a book and it shows you the same thing except it says the PaCO2 divided by 0.8, it's the exact same number, it's just a different way to get it. But we do better, yeah. Multiplying is better. So if we took this and broke it down to make your life a little easier and keep your head from hurting, what's the barometric pressure in most places? 760. So unless you're in Denver or underwater, the barometric pressure is going to be 760. Pressure of water is a constant. It's 47. And this is still going to be the CaO2 times 1.25. But if our life is happy and we have 760 barometric pressure, then this is always going to be FiO2 times 713. So, and that's the easiest way to remember it. Just know if your barometric pressure is different, the number might be a little bit lower. So you'll do your FiO2 times 713 minus your PaCO2 times 1.25. And that will give you your P big A O2. Yeah, it is. Yes.
On the board, will the barometric pressure be given to us?
Yeah, and it's usually 750. So in that case, your number would be 703.
Okay.
Yep. On the boards, the barometric pressure is usually 750, but we're not going to do this calculation by the time we get to fifth term because you'll learn other things by then. Hold on, Ruthie.
What's the pH2O stand for again?
Partial pressure of water.
Is that always 47?
Yes.
Where you got that.
This is a constant. 47 does not change.
Okay.
So the only number that could change would be your barometric pressure. So pay attention to it. So let's take as a first example, and we're going to do a whole bunch of examples. So let's just take us on room air, okay? FiO2 times 713, and remember you've got to change it to a decimal. So you will always just put, if your FiO2 is 80%, put a dot in front of it, 0.8. The only time that changes if it's 100% and then you're multiplying times 1. Make your life easy. So remember, this is the biggest mistake. Well, it's one of two big mistakes people make when doing this. make sure you change your FiO2 to a decimal, which is nothing more than putting a dot in front of it, unless it's 1. And then let's take our normal CO2, which is 40 times 1.25. And this is gonna equal 149.9 or something like that, which can be rounded to 150 minus 50, or somewhere close to that. Huh?
Is that 0.21 for that FiO2 equals
0.21 times 713. I think it's technically minus 51 or something, but, so what does this equal? It's right around 100. Huh?
So do we round up,
Yep.
round
You
up
can
already,
round this one to a whole number.
which would be 150,
Yeah.
and then minus 50, okay.
Yeah, that's why I put that in parentheses. So that means when I'm breathing room air, and which is what we're doing right now, this was us right now. Our CO2 is around 40 because we're not hypercapnic or we'd be passed out. None of us are hyperventilating, at least not yet. And we're breathing room air. So so this is telling us the oxygen that's getting to the alveolar level would be 100. Right? And then what's a normal PaO2? 80 to 100. Now, you're never gonna get the exact same amount from here to here. You're always gonna have some stragglers along the way. But by doing this, you can see that the normal because what you always have to remember is to subtract now, so then to get your gradient, you're gonna take the P big A, this is a crummy marker, minus the little a, because that's the last step people forget. And that will equal your gradient. So if my PO2 was 90, my gradient would be 10. If it was 95, my gradient would be 5 in this example right here. What's your question?
How did we go from 149.9 times?
It's minus, no, it's huge, I forgot the difference. See, that's
Oh.
the deal.
Let me just do that, make it like easy.
150 minus.
Oh, so you just rounded it.
Yeah,
Okay.
She rounded 149.9 to 150.
sorry guys. Yeah, I just rounded it. So this was 150 and this is 50. I can tell you an easy way for those of you who get my little hints. 40 times 1.25, you're taking a quarter of the number. So in this situation, it's 10. Quarter of 40 is 10, and you just add it, and that makes it 50. You can do it without. So if your CO2 was 80, a quarter of it is 20, and then just add it, which would make this number 100. That's why I like multiplying. Because you can a lot of times find little shortcuts, ways to do it in your head.
Can you say that one more time, please?
Yes. If you're gonna multiply times 1.25, you're gonna take whatever the number is, and so 1 we know is gonna be 40, and then I need a quarter of it for the 0.25. So a quarter of 40 would be 10.
Right.
So without doing the math, I know that I need to add 40 plus 10 to make my number 50. See?
Okay,
Got it? Just like I said, if the CO2 was 80, it's gonna be 80 plus a quarter of 80, which is 20. So 80 plus 20 is 100. And now you just kept yourself from doing longhand math. Okay, so you're just gonna take whatever the P big A is minus the little a, and that will give you your gradient. For our purposes, the normal AA gradient is less than 25. You'll see some sources that say 5 to 10, which is not wrong.
what does the book
But-
say?
Hold on, the book says, no, I'm gonna tell you what, remember I always tell you what you need to know, don't worry. So, the book is gonna tell you 5 to 10 is normal. for your standard young, healthy population. We don't deal with young, healthy people. We deal with sick people. If they're young and healthy, they don't wanna see a respiratory therapist. So, as people age less than 25, so it's 5 to 10, but it can go up as high as 25 in the elderly people. So we just say less than 25. And trust me, you're gonna find out that even if it's 50 or 75, I don't care anyways. So it's never gonna get that technical. So if you know less than 25, you'll be fine. On any test, including your boards. Because we're gonna deal with big numbers. We don't care about little numbers in this situation. So make sure you guys all have this written down. And then I'm gonna write a bunch of ABGs on the board and we're gonna practice and I'm gonna show